Okay, guys. Okay, I think we are online. Okay, and we will start as well. Okay, just to check whether you guys can hear me. Okay, Andrew, can you hear me? Just give me a thumbs up, then we will continue. All right, good. So let's actually continue while the others will join later. Okay, so we are going to look into this MCQ paper from October, November 2024. Okay, so the paper is 1 hour 15 minutes. Okay, let's try the question. Okay, we will go a little bit slower here. Okay, so here, okay, you can have which species contains a different number of electrons from the other three. So if you want to solve this, okay, we need to look into the number of electrons. Okay, so number of electrons, this is going to be Cl is 17. Okay, don't look at the mass. Okay, you can refer to the periodic table. 17 plus 4 times 16. Okay, sorry. So 4 times 8. Okay, 8. And then this is 2, 1. Okay, then this one is going to be, so if you want to look at for sulfur, okay, quickly you can just look over here. Okay, we will look into the 16, yeah, the one on top. Okay, so electrons. Okay, electrons. So this is going to be 16. Okay, plus 4 times 8. So this will give you 17 plus 32. Okay, 17 plus 32. That is going to be a total of 49. Okay, but there is negative one electron over there. So it's going to be plus 1, so 50. So this is 2 plus 16, okay, plus 32. So that is going to be also giving you 50. So same number of electrons. So for this is 16 plus 4, okay, times 8. Then there is 2 more, so plus 2. So 16 plus 32 plus 2, that is going to be also going to be 50. For TE, okay, 2 minus, okay, let's look at the periodic table. Okay, for TE is somewhere tellurium. Yeah, so this one is 52. And 52, and the ion is going to be 2 minus. Okay, so you are going to have 52 plus 2, total 54. So different number of electrons is tellurium. Okay, so D will be the answer. Now, for the next, let's go for the next question. Now, which factor causes helium, okay, to have a higher first ionization energy than hydrogen? So hydrogen is 1, 1, helium is 2, okay, 4. So we look into the proton numbers, okay. So whether they are paired and so on doesn't matter, okay. The important thing is the proton number. The more nuclear charge or the more number of proton, okay, will have more attraction towards the electron. So in this case, okay, you can see the nuclear charge of helium is higher compared to hydrogen, and that will be the answer. If we are looking into the shielding effect now, shielding effect, you see this is 1s1 and this is 1s2. Okay, shielding effect is going to be the effect done by the complete inner shell of electron. There is no inner shell over here, so nothing to do with shielding effect. And if you look into, okay, let me share this again. Okay. Okay. If you look into, okay, erase this. Okay. If you look into the factors, okay, for the shielding effect, definitely it's not going to be the answer. Okay, so this is going to be not the answer. Now, and then the lowest energy level is filled. Okay, 1s is paired. No, that will not be the answer. So the answer is going to be C. Okay, nuclear charge in helium is higher than hydrogen. Now, let's look at question number 3. Okay, so you have this particular sample, okay, aluminium carbide. So Al, let's say we put it X, okay, C is going to be Y. It's reacting with excess of water, okay, to produce methane gas. So reacting with water to give you methane gas, CH4. Okay, so this is the only carbon containing product. So this carbon containing product is coming directly from here. Okay, so this methane gas burns completely with oxygen. CH4 burns completely with oxygen to form water and carbon dioxide. Do take note that all the carbons will be coming out as in a form of carbon dioxide over here. Okay, so here, okay, they say that the volume of carbon dioxide produced at room temperature and pressure is 108 cm cube. So if this is 108 cm cube, what we can find out is going to be what is going to be the number of moles, okay, of carbon dioxide that is going to be given out, because we know that every 1 mole, okay, of any gas gives you 24 dm cube. So you change it into cm cube, 24,000 cm cube, okay, of gas, okay. So now if it is going to be 1 cm cube, it means going to be 1 divided by 24,000. Okay, so that is going to be mole. So I want to find out for 108 cm cube. So I times by 108. Okay, I times by 108. So how many moles is that? 1 over 24,000 times 108. Okay, you will get this. Okay, so I want you guys to help me to calculate. Maybe ZE, can you help me to calculate and tell me the answer?
Uh, 4.10 to the power of negative 3.
4 point.
5
Mhm.
times 10 to the power of negative 3.
Okay, we take in this case, okay, 4.5 times 10 to the power negative 3. So that is going to be the number of moles. So here, okay, if you have, okay, certain number of moles of carbon dioxide, it means that the number of moles over here must be the same. Okay, it's going to be the same. So this one is 4.5 times 10 negative 3. So what I can do now is to find out, okay, what is going to be the mass. Okay, if I find out the mass of the carbon here, the mass of carbon here, I can find out the mass of the carbon over here. It's still going to be the same. So what I can do now is going to be using the number of moles. Okay, number of moles equals to mass divided by mr. In this case, I'm going to find the area of C, carbon only. So it's going to be 4.5 times 10 to the power negative 3 equals to mass, okay, of the carbon itself, okay, divided by the carbon is 12. Okay, carbon is 12. So I want you to calculate for me, okay, the mass of carbon, yeah, in methane, okay, which is going to be 12 times 4.5 times 10 negative 3. What is that? Yeah, so ZE help me to calculate, yeah, throughout.
0.04.
0.054.
0.054.
Okay, this is going to be the mass, okay, gram. Now, if you look at this mass, okay, so if I take the mass over here, if you have the aluminium carbide, okay, aluminium carbide, the entire sample, okay, is going to be 0.216, okay. So if I want to find the mass of aluminium, okay, mass of aluminium, okay, mass of carbon, I already found out, which is going to be 0.054. Okay, what is the mass of aluminium? It's supposed to be 0.216 minus 0.054. Okay, ZE, help me to calculate.
0.12.
Repeat again, 0.1.
62.
162. Now, so here, okay, if you have aluminium 0.162, and then you have carbon, which is going to be 0.054, okay, we can change it into, let's say we find the ratio, yeah. So this one is 12, okay, this one is going to be aluminium is, okay, you can check, it's going to be 20, aluminium is 27, okay, so we will use 27 for our calculation. So divide by 27. Okay. What is the value for aluminium if you divide by 27?
6 times 10 to the power of negative 3.
Okay. This one just now also we have the answer 0.054 divided by 12. What is that?
4.5 times to the power of negative 3.
Okay. So earlier, yeah. So this one. Now the ratio between them, okay, find out the ratio. The aluminium ratio with carbon, okay, is going to be, which is aluminium divided by carbon, is going to be 6. You can cancel 10, negative 3. 6 divided by 4.5. What is that value?
1.333.
Okay, 1.333. So it means that there is more aluminium than carbon, yeah? Okay, so this one will not be the answer. Okay, possible to have the answer. Okay, cannot be the answer. Possible to have the answer. 3 divided by 2 is 1.5. Okay, 4 divided by 3 is
1.333.
yeah. So therefore, the answer is E. Okay, I think you need to calculate this properly. Yeah. So let's actually move on. Thank you, Z. Yeah. So a reaction between two gases takes place on the surface of the catalytic converter of petrol engine car. In this reaction, 4 reactant molecules produce 3 product molecules. Okay, what could be the 2 reactant gases in this reaction? Okay, so 2 gases, okay, on the surface of catalytic converter, yeah. So if you look into catalytic converter, okay, the gas that will react is going to be nitrogen monoxide and carbon monoxide, okay, where they will react to give you, okay, nitrogen gas, and they will give you carbon dioxide gas. Okay, so you need to know, okay, this equation, okay, where, okay, this one, if you balance this up, okay, there's 2, okay, I put 2, and then there is 2 here, I put 2 there. Okay, so in total you have, okay, 2 nitrogen, total 4 oxygen, so that should be 2 here. Okay, so this is balance, okay, the equation. So they say in this reaction 4 reactant molecules, 2 molecules from here and 2 molecules over here. That is what they meant by 4 reactant molecules. Okay, so to produce 3 product molecules, so 1 and 2, total 3 product molecules. Okay, so therefore, okay, this is going to be, okay, therefore, okay, this is going to be, the answer is going to be C. Okay, so please remember. Now, for number 5, okay, an ion contains 1 nitrogen atom, okay, and 2 hydrogen atom. Okay, now, so you have 2 hydrogen atoms, okay, it has nitrogen, hydrogen bond angle of approximately, okay, 105 degrees. Okay, which row is correct? Okay, we need to know that nitrogen, okay, they are from group 15. Okay, nitrogen, they are going to be from group 15, so they have 5 valence electron. Now, out of these 5 valence electrons, so you have 2 electrons are being used to be bonded with the hydrogen. So we still have, okay, 1 pair of electron, and another one more electron. Total 3 electrons are there, okay, which is going to be giving this particular structure. Yeah. So when they say number of okay, they say an ion. Yeah. Okay. So they did mention is ion. Okay. We don't know which ion. Okay. But if let's say if the charge is going to be -1, it means that the one of the electron from outside is coming over here. Okay, it means it is going to make the lone pair to become 2. Okay, the number of lone pair is going to be 2. Okay, that's possible. Okay, possible answer. But if you have +1, okay, one electron is gone. Okay, one electron is gone. The number of lone pair, okay, that is going to be around the nitrogen, okay, might be only one. Okay, one over there. Okay, so here, okay, we need to decide, okay, between the answer which is going to be A or D. So this is when the bond angle comes in. Okay, the bond angle comes in. So if you have nitrogen, okay, with one lone pair, 2 like this, and if you have nitrogen with 2 lone pair, okay, and 2 like this, okay, this shape is going to be similar to non-linear, okay, which is going to be similar to water molecule, which is going to be 104.5. You can see it's almost similar to that. Okay, but if you follow this shape, okay, it's going to be something like a trigonal planar, but because there is a lone pair over there, okay, they are not going to be 120. They will become less than 120, but possibly maybe 117 and so on. It is impossible to get 105 degrees over there. Therefore, the best answer over here is going to be D. Yeah, so the answer is going to be D. All right. Now, let's move on. Okay. So the next question. Okay. So why does ICL has a greater higher boiling point than BR2? First thing that you can actually notice, this is going to have only ID. Okay, is a non-polar, and this one is going to be polar molecule. So definitely PD. Okay, when we say about boiling point. So let's look at the answer over there. Because difference in bond energy, no, we are not breaking the bonds between ICL and the BR and BR. Okay, we are not breaking that bond. So this will not be the answer. Okay, because the difference in electrons, nothing to do with that, because we are not talking about just the ID. There's also PD over there. Okay, so if you are comparing between non-polar and non-polar, it's okay, fine. Okay, but here there is PD. The difference in polar nature, yes, possible. Okay, but let's look at D, because the difference in relative molecular mass. Now, relative molecular mass is going to be just an indication to tell that if you have a greater molecular mass, you have more electrons, then you have more ID. That's it. But since we have PD, therefore the answer is going to be B. So we will stick to our answer, which is going to be B. Now, let's go on for question number 7. Now, in this question, you may assume that nitrogen behaves as an ideal gas. So this one, they have given you the atmospheric pressure. So they say which volume 1 gram of nitrogen is N2, occupy this and occupy this. Okay, if 2 atmosphere, so this one atmospheric pressure is going to be 202 kilopascal. So we are going to use PV equals to nRT. Okay, so the pressure, okay, change it into Pascal. Okay, so 202 times 10 to the power of 3. Okay, volume, okay, we want to find, leave it over here, volume. The volume we will get in meter cube later, yeah. So N, okay, is 1. Nitrogen, okay, is 7 and 14. If you are not sure, okay, you can always double check. Okay, nitrogen 14. Okay, so it's going to be 14. Okay, 1 over 14, and then that's 2, yeah. So I'll leave it as 28. 8.31, okay, that is going to be the R. You can check from the constant. And then the T, okay, you need to change this, okay, into Kelvin. So you need to add 273. So 50, so 3, that is 2, 3. Okay. So I need to find out what is my volume. Okay. So ZE, help me with this, yeah. So 202 times 10 to the power of 3 times 28 divided by 8.31 times 323.
Uh, 2,100
2,107.
and 7.2.
0.2.
Yes.
Okay, that is going to be in cm cube. Something is wrong. This question, nitrogen behave as an ideal gas. 1 atmospheric pressure is this. Okay, 1 gram, 8.31. Okay, anyways, this one is in meter cube when you calculate. So you need to change into cm cube. Can you calculate again? Maybe someone else? Also, the rest also try to calculate.
Sir, it's 474.
400.
74.
Okay, this one, yeah. So you will get your answer in meter cube. Okay, then after that, you need to times by okay, you need to times, okay, because you want to get answer, okay, from meter cube. Okay, you want to go to cm cube. Okay, you need to times by 10 to the power of, because 10 negative 2 times 10 negative 2 times 10 negative 2. So you need to times 10 to the power of 6. Yeah. So you times, and then you're supposed to get this answer. Okay. So just convert, okay, and then calculate accordingly. Okay. So this one, okay, if you calculate, should be able to get the answer properly. Can I have another one person who try to calculate and get 470? Andrew?
Yeah, it's 470, sir.
Okay, so we move on, yeah. Now, so which statement about the properties, okay, associated with different types of bonding involved, okay, is correct? Okay, any covalent compound that contains both oxygen and hydrogen in its molecule form hydrogen bond. This one, okay, doesn't mean that you have oxygen and hydrogen in your molecule and then you are going to get a hydrogen bond. For example, I give you one example. If you have C double bond O, okay, and then H over here, okay, if you are looking into delta negative, okay, it will be here, okay. But this hydrogen, okay, they do not have any delta positive. So if you have any aldehyde, okay, and you have another aldehyde, there is going to be delta negative because H is not delta positive, okay, there is not going to be any hydrogen bonding over there unless, okay, if you have like, for example, C double bond OOH, okay, in this case, you have this electron being pulled by the oxygen. This is delta positive, okay, can be delta negative here, can be also delta negative here. So if I have carboxylic acid, okay, if I have like this, and okay, we know that, okay, this one also will be pulled delta negative, delta positive. So delta positive and delta negative can form, okay, hydrogen bonding, but not all, okay, not all can form hydrogen bonding. Therefore, that one, okay, that statement is incorrect. Okay, ionic bonds, okay, and covalent bonds cannot occur in the same compound. Okay, that is wrong. Yeah. Okay, they can actually exist, okay, in the same compound. Okay, example, okay, let's say for example I have NH4 NH4 ionic bonds and covalent bonds. Okay, covalent is inside. Okay, Cl, ionic and covalent bond. Okay, actually they can occur. Okay, I couldn't actually find a proper example over here, but let's actually look into different statement first. Okay, ionic compound differ, okay, from metals in the ionic compounds. uh Ionic compounds differ from metals. Ionic compounds do not conduct electricity in solid state. Yeah. Okay, this is correct. Okay, ionic compounds, okay, they do not conduct electricity in solid state because no free moving ions. Okay, but metal, okay, they conduct electricity in solid state. So that will be the best answer over here. Okay, the only covalent compound with high melting points is hydrogen bonds. No, the one covalent compound with high melting points can be also graphite. Okay, can be also the giant molecule diamond. Okay, so all this. Okay, so C will be the answer for this. Number 9, enthalpy change for formation. Okay, to form 1 mole of a substance from its elements. Okay, from its elements under standard state. Okay, under standard state. So let's look at first must be 1 mole of the compound. So 1 mole, 1 mole, 1 mole, 1 mole. Okay. So we check on that 1 mole. Okay. And then once you have the 1 mole, it must be from the elements. Okay. So this one, they are not elements. Okay. So cannot be the answer. Okay. This is not element. Cannot be the answer. Okay, in this case, element, 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 element. Okay, so why A is wrong over here? Okay, A is wrong because carbon, okay, is going to be under standard state. Carbon is solid. Okay, carbon is not gas. Okay, therefore, it must be this half and half. Okay, gives you an O. So this one is the answer. Okay, let's move on. 2 standard enthalpy change of formation. The moment you see formation, please use my method, okay, of the arrow. Yeah. So 3VCl2, 2VCl3 plus V. So formation, okay, this one, the arrow will go here. Okay, the circle will be in the middle. So the arrow, so 3 times, okay, VCl2. So 3 times negative 452. So this is what we are looking for. And then this, okay, to form this, 2 times negative 573. This is V is going to be 0. Any elements, okay, to form them is going to be 0. Okay, so let's actually put them clockwise equals to anti-clockwise. So this one, clockwise, clockwise, anti-clockwise, anti-clockwise, follow the circle. So here, 3 times negative 452, okay, plus, okay, I put it as x plus x equals to 2 times negative 573. Okay, x equals to 2 times negative 573 plus 3 times 452. Okay, become positive. So you help me to calculate this. Okay, if you can confirm this plus 210, then we will move on.
210, sir.
Okay, so let's move on. Yeah. Okay, 11. Equation for some of the reaction of hydrogen peroxide are given. Okay, so hydrogen peroxide, hydrogen peroxide, hydrogen peroxide. Now, in which reaction is hydrogen peroxide is acting as reducing agent? Okay, so if it is acting as a reducing agent is going to reduce others, but itself will undergo oxidation. Okay, oxidation. Okay, so it means they may receive oxygen and so on. Okay, so let's actually look from the equation. Okay, in this case, let's look which one is easier to find out. Yeah, so here is plus 2 and this one is plus 3. Okay, so you can see it is going to be more towards this is going to oxidize Fe2 plus. Okay, so oxidize, so cannot be number 1. Okay, And then here, okay, if you use mn over here, this is plus 2. This one, if you want to calculate, x plus negative 8, okay, 4 times negative 2 equals to negative 1, okay. So x equals to negative 1 plus 8, so plus 7, yes. We know this is acidified potassium manganate 7. 7 to plus 2 is going to be reduced. So this is possible to be a reducing agent, okay, reducing agent. And we can see also it has lost, it has H2O2. It has yeah, I think rather than that, just straight away look over here. Possible, yeah. So here, okay, 3 to 2. Okay, so you can see it is going to be reduced. Okay, reduced from plus 3 to plus 2. So possible is going to be a reducing agent here. So therefore, the answer is C, 2 and 3. Okay, we move on. Now, the equation for the reaction of thiosulfate ion and the aqueous dioxovanadium ions is shown, okay, in the equation. Which row shows two correct statements about the equation over here? Now, first of all, let's try to balance it first, okay, rather than looking at the answer. Okay, so how to balance? This is going to be trying to balance using oxidation number. Okay, so let's look at the oxidation number of V first, okay, V. So the oxidation number over there, let's say V is X, okay, minus 4, okay, 2 times negative 2 equals to plus 1. So X equals to plus 1 and plus 4 is 5, okay, so this is 5. So this one is X, okay, minus 2 equals to plus 2, X equals to plus 4, okay, so this one is 4. From here to here, there's going to be a decrease of 1, okay, oxidation number, okay, decrease of 1. So now we will look for this and this, okay, from here to here. Okay, let's look. Okay, so 2x, okay, 2x plus 3 times negative 2, okay, equals to negative 2. 2x minus 6, negative 2, 2x. So here is going to be plus 4, x equals to plus 2. So this is plus 2. So here, 4x plus 6 times negative 2. So negative 12, okay, equals to negative 2. 4x equals to, that one is plus 10. X equals to 10 divided by 4. Okay, 10 divided by 4. Okay, that's going to be 5 over 2. Now we get something unusual here. Okay, now in this case, okay, 5 over 2, I think let's look at the number also. Yeah, 5, S2 and S4. Actually, 5 over 2, we can just take it as 5. Okay, but I will actually try to solve it over here because this is 2. Yeah, 2 and 4. Okay, so if we look over here, plus 2 to become 5. Okay, that's going to be plus 3 total. Okay, plus 3. So in this case, to eliminate the electrons, I need to times by 3. Okay, I need to times this by 3. So this value, okay, and this value should be 3. Okay, should be 3. Okay, change in oxidation. Oh, I think no need to even balance it. Yeah, they say change of oxidation number in vanadium. Okay, vanadium, you see, it was from 5 to 4. Okay, let's see. This is wrong. 5 to 4. 5 to 4. No. Okay, and then they mentioned that X and E must be the same, okay? Because why? 3 and 3, yeah? Okay? Here, whatever that I times over here must be the same. So here must be the same. X and Z must be the same, okay? And then the value of this, half or quarter. Okay, half or quarter, let's check. The value of Y. Okay, Y, let's check Y. Okay, if you have, okay, here, hydrogen is going to be 2H, that is 4, okay? So this value, okay, must be 4 over here, okay? So if this is 4, okay, so if you have 3, okay, 4 half of the value of y. Half of the value of quarter of the value. Okay, let's actually look at it again. Yeah. So they mentioned that, okay, the value is going to be the same value. Yes. Okay, can. Okay, but whether it's going to be quarter the value or half of the value. Okay, the y supposed to be here. We know 4. Okay, so 2. So the h is must be 4. This is 4. If we take this as 1, then it's going to be quarter, but this one is half. This is half of value, then this must be 2. Okay, I'll check on this. Yeah, we'll come back on this again. Okay, so let's move on. Okay, let's move on. But the answer is going to be C. Okay, between this, I'll explain to you again. I'll check again. Now for 13, okay, when some solid, okay, is added to a beaker of water, okay, and equilibrium is set up, okay, which compound when added to the equilibrium mixture, okay, increases the amount of this present. So we want to increase or to form more of this, okay. So how do we increase that? Of course, by increasing all this. So here, okay, when which one added? So ammonia, no. Okay, ammonium. Let's look at the one that is available here. Yeah. So ammonium, okay, chloride is not there. Okay, this is all not there. Okay, so in this case, let's actually look at what may react, okay, with the OH. Okay, something that will react with OH will remove, okay, will remove the it will, when something is added, okay, to the equation, increases the amount. Okay, so when you add, okay, ammonium, okay, when you add ammonium, ammonia will react. Okay, basically ammonia will add, right. Okay, let's look at ammonia plus H plus. Okay, they give you ammonium. So this one base, so this is acid. Okay, so this is acid. If you add acid, you remove, okay, this one, it will go this way. Cannot. Okay, acid cannot. Okay, it will go this way. Sodium chloride, okay, do not have any reaction with this. The only possible is ammonium. Ammonium, it's kind of okay, when you react with water, okay, ammonia, okay, when you react with water, okay, they will give you ammonium and OH minus ion. Okay, it means that you are increasing OH ion, okay, when you add ammonia. Okay, therefore, okay, once OH ion increases, you are going to have more precipitate of this. So the answer is going to be A. Okay, so let's move on. Okay, 13 is A. Now 14. Gaseous hydrogen and gaseous iodine react to form gaseous hydrogen iodide. So here you are going to actually place them, okay, in a sealed container. Kc value is 9. Okay, so here if I have H2, I2, and then HI, so 2. So if I use ice method, so this is product. Okay, in earlier product, there's nothing. Okay, but you are using 2 moles of this, 2 moles of this, and then volume is 1. Okay, the Kc value, okay, is 9. So Kc is going to be Hi, okay, to the power of 2 divided by H2 and I2. Now Kc is 9. how many moles of hydrogen iodide are present at equilibrium? Now, at equilibrium, let's say I put as X, okay, over there. So let's say here is plus X. So this one is minus X, minus X. So this will be 2 minus X, 2 minus X, okay. So 9, okay, equals to the HI is X. So X to the power of 2. So this one will be 2 minus X, 2 minus X, okay, equals to 9. And then, okay, we need to find the X value, okay. So let's see, I think becoming like maths equation now. 4 minus 4X plus X squared, okay, it's going to be 36 minus 36X plus 9X squared equals to X squared. So this one will be 8X squared minus 36 X plus 36 equals to 0. So X, don't know related to this. So maybe we just replace the values. Okay, just replace the values. So if it is going to be 0. Or use your calculator, Andrew. Can you solve this equation?
I got 3 and 1.5, sir.
3 and 1.5.
Yeah.
3 is it negative or positive?
Both positive, sir.
3 and 1.5. Shouldn't be. Okay, because the answer is 2.4. In an experiment, 2 and 2 placed in seal. Okay, then 1 dm cube. Kc value is 9. How many hydrogen iodide are present in equilibrium? X, 2 minus X, 2 minus X. This value will be the same. This is X. X. 4, 2X, 2X plus X times 36, 4, 36. Then 9X plus X squared. How many moles are present? Okay, let's try again.
Sir, is it not because there's 2 HI?
Yes, correct.
So times 2.
You need to times by 2. Okay, correct. Okay, it is because of that. Okay, this 2. So this one, okay, is going to be when there is going to be X. So this one should be half of it. So should be minus this. So here will be 2 divided by 2. Okay, using that, we calculate. X squared 2 minus X over 2, 2 minus X over 2. You help me to calculate this. This is going to be 4 over 2, 4 minus X over 2, 4 minus X over 2, 9. This will be 4, 4 minus X, 4 minus X, is 2, 9. 9 times 4 minus X. in minus 8x plus x squared. Okay, help me to calculate. What is x? Use your scientific calculator. Or the easiest method is just to replace the values, yeah? Yeah.
2.4 or 12
Or
12.
or 12. So you do not see any 12, so the answer is 2.4. Okay. So D. Okay. Good that you noticed that. Okay. This number, yeah. So next time let's actually focus on this number. Okay. Be careful with the number 2. Okay. So the hydrogen iodide. Okay. So I'm using X as which is representing 2. Yeah. Now let's move on. Okay, so 15. Why does the rate of gases reaction increases when pressure is increased at constant temperature? So when pressure is increased, okay, so they are going to have definitely no more space. Yeah, so that is wrong. Okay, the particles move faster. They are frequent collision because there is no more space between them. Okay, they are going to be frequent collision. So that will be the answer D. Okay, so 16. The Boltzmann distribution for a mixture of gases capable of reaction, okay, is shown. So the two gases, you have 25 and 35. So remember, this is going to be for 25 degrees Celsius. The one that is going to be, the peak is shorter, and to the right is going to be 35 degrees Celsius, okay. And then, okay, they say the activation energy are shown and so on. Which row is correct? Okay, so number of particles with enough energy to react with 25. So number of particles with enough energy, okay, in catalyze. So with catalyze is this one. So Y plus Z. Yeah, Y plus Z. This one. Okay, number of particles with enough energy for 35 in uncatalyzed. So uncatalyzed is this. Okay. So the one that is going to be for uncatalyzed is X plus C. X plus C. So the answer is D. Okay, let's go on. Now, which oxide is insoluble, okay, in aqueous sodium hydroxide? Sodium hydroxide is basic, okay, so something that will be soluble are acidic, okay. So acidic oxide, non-metal oxides are acidic oxide. Amphoteric, okay, definitely can react with sodium hydroxide, so they do react, okay, do react. Magnesium oxide will be the answer because magnesium oxide is a basic oxide, okay. So basic oxide cannot react with a basic solution. Okay, 18. Sodium and sulfur are burned separately in oxygen. Yeah, if you memorize the colored flame, this one will be very easy for you. So sulfur, please remember blue flame. Okay, and then sodium, please remember sodium is yellow flame. Okay, so the answer is going to be C. Okay, so this one requires your memory. Yeah, but definitely blue flame you should know. Okay, sulfur is blue flame. Now, X and Y are elements in period 3 of the periodic table. So period 3, let's say they are period 3 from here. Y has a greater atomic number than X. So maybe Y will be here, X will be here. So from left to right. Now, the stable ion, okay, formed by Y has greater radius, okay, than the stable ion formed by X. Now, so it means that the stable ion by X must be a metal ion, okay, metal ion, because if let's say they have valence electron 1, 2, or 3, when this electron goes out, okay, the size will become smaller. But for Y, if it is going to be non-metal, okay, non-metal, they are going to receive electrons, so the size remains almost the same, okay, almost the same. So that will be the explanation for this. The stable ion formed by Y, okay, has 18 electrons. Okay, so it has 18 electrons over here. Okay, 18 electrons, 2, 8, okay, and then 8, something like that. Now, which row is correct? Okay, which row is correct? Number of electrons in stable ion of X. So do remember, X should be 2 and 8 lah. Okay, stable ion will be maximum 10. Okay, must be between this. An element with greater atomic radius, okay, the element with a greater atomic radius, if you atom only, okay, do remember atom wise, this will become smaller and smaller as they go across, okay. So X is definitely going to be greater, okay. If it is going to be just atom only, yeah, so A will be the answer. 20. Okay, X is a group 2 element, okay, either in period 3 or period 5. Okay, so XOH2 is less soluble. Now, if it is less soluble, do remember going down the group, okay, solubility increases. Okay, if it is less soluble, it means X, okay, it's going to be at the top, okay, and then X definitely going to be at the top. Okay, so X is less soluble compared to calcium hydroxide. Now, calcium hydroxide, so must be before, okay? If it is going to be less soluble, before calcium. Okay, let's look at what can come before calcium. Okay, either these two, yeah, beryllium and magnesium. Okay, so cannot be strontium. Okay, beryllium or magnesium, so magnesium. Then they say when this is heated, it will decompose. Do remember, so if magnesium nitrate, okay, when they are heated, okay, they are going to give you magnesium oxide, okay, nitrogen dioxide, and oxygen gas. Okay, so cannot be X only. Okay, can be, okay, cannot be X only. Okay, we want to choose A and B. So definitely the answer is going to be B. Okay, must be oxide, okay, nitrogen dioxide, and oxygen. Okay, nitrogen dioxide is a brown gas. Please remember that. Now, 21. Which one comparing magnesium, barium, group 2? Okay, magnesium is at the top, barium is at the bottom. Okay, so magnesium, okay, react with more rapidly. Please remember, reactivity for metals going down, they are going to be more reactive. Okay, more reactive. So barium should be more reactive. So A is wrong. Okay, and then let's say 1 mole give greater amount of gas when it reacts with excess than 1. Okay, this one involves calculation. Let's actually hold on to that first. But this one, solubility, magnesium sulfate and barium sulfate. Please remember, sulfate going down the group, solubility decreases. Okay, so magnesium sulfate solubility is greater than solubility of barium sulfate. This is definitely going to be correct. No need to worry about B, no need to worry about D, and so on. But if you want to look at D, magnesium carbonate undergoes thermal decomposition less readily than barium carbonate. Please remember, going down the group, okay, the thermal stability decreases. Okay, the thermal stability increases. So it means that, okay, the carbonate is going to be difficult to be decomposed. Okay, so in this case, that is wrong. Okay, we want the correct. Okay, so magnesium carbonate is supposed to be easily decomposed than barium carbonate. Yeah, so the answer is C. Let's move on. Okay, this is very common question. Okay, that we need to focus on. Okay, the solubilities, okay, of these halides in aqueous ammonia also differ. Okay, so which one is correct? Silver bromide. Do remember, white, cream, yellow. Okay, so now they're talking about cream. Cream, okay, silver halide that is most soluble in NH3. So the one that is most soluble, okay, if you compare, yeah, the one with dilute ammonia will soluble will be AgCl actually. Okay, So AgBr will be only soluble in concentrated ammonia. Okay, for AgI, okay, they are not soluble in concentrated and dilute also. Okay, so the answer is going to be A. Now 23. So chlorate is used for anion containing chlorine and oxygen only. In a molecule of ICl, okay, the iodine atom, okay, has oxidation number of X, and the chlorine atom has oxidation number of Y. Okay, so when you have you added, okay, then the iodine is reduced. Okay, so iodine here is 0. Okay, and here, okay, ICl. So they say in the iodine, okay, they just give number. Okay, reduce. Okay, ICl. Okay, assume, okay, that, okay, we cannot assume also. Let's actually read through. Okay, so here, okay, they say the ICl iodine is reduced, okay, from big number. Okay, big number to smaller number. So I must be bigger number. So let's try. So if Cl, okay, and I, they are group 7, so -1. So let's say I is X, okay, I will use X. And then Cl, I'm assuming is -1 equals to 0. X is +1. So 1 to become 0 possible. Okay, 1 to become 0 is possible. So I'll take it as 1. Okay, X is 1. Then Y, I'm taking it as -1. Okay, for Cl. So which one, X and Y, is correct? X is the same oxidation number as the number of Cl when Cl2 is added to coal and AOH. Okay. X is the same as oxidation if Cl is added to coal and AOH. Okay, this one I want your help. Okay, ZE, can you check KCl2 plus NaOH? What is the equation for the coal? And then Cl2 with NaOH when it's hot. Hot coal. You will get
Cl2 with cold is NaCl plus NaClO plus H2O.
NaClO plus H2O. Okay. Then this one should be NaCl plus NaClO3. Okay, the hot. Am I correct?
Yes, sir.
Okay. So now they are asking corresponding. Okay. So they say X is the same oxidation number of Cl in the chlorate ion form with coal. Okay, let's see this one. So 1 plus X plus -2 equals to 0. X minus 1 equals 0. X equals to 1. Okay, X equals to 1. Yeah. Okay, X equals to 1. Correct. Okay, if we follow this one, then it's going to be 1 plus X minus 6 equals to 0. X minus 5 equals to 0. X equals to 5, which is incorrect. Y is the same oxidation number. Okay, if it is going to be coal, yeah, cannot be. Okay, because Y is -1. This one cannot be also. Okay, so answer is A. 23A. 24. Okay, which statement is correct? Now, so which statement is correct? Okay, so ammonium ion, okay, is basic due to the lone pair of electrons. So you see here, ammonia okay, is basic. Okay, but when they have H plus, because ammonia can receive, it's a proton acceptor, they will form NH4 plus. But do remember, once they form NH4 plus, they have tendency to donate the H plus. So they can, they are acidic actually, conjugate acid. Okay, so acid. Okay, just think is acid. So this one to say that they are basic itself is wrong. Okay, it's wrong. Then nitrogen monoxide, okay, react with PAN. Remember just now, NO react with PAN to produce a component in photochemical smoke. Okay, so PAN. Okay, how do you get PAN? Okay, nitrogen monoxide react with unburned, okay, hydrocarbon, which is known as VOCs. Okay, then only they will give you PAN. Okay, NO will not react with PAN. Okay, please remember that. Okay, so they will react with unburned hydrocarbon to give you PAN, which is PAN. Okay, this is PAN, which is going to be the component in photochemical smoke. So no. Okay, so nitrogen dioxide catalyzes the oxidation of sulfur dioxide. Yes. Okay, please remember this. Okay, if you want sulfur dioxide, okay, to change into, okay, O2 to change into SO3, actually nitrogen dioxide is the catalyst. Okay, so this is correct. Okay, so nitrogen is very unreactive, not because of this. They are unreactive because of the presence of triple bond. Okay, so that is going to be answer C. 25. Okay, now we are going to go into the organic compounds here. Now, 25, okay, the diagram shows the structural formula, okay, of hydrocarbon molecule Q. How many carbon atoms in Q are sp3 hybridized? Sp2 hybridized. Sp2 hybridized is 1s, 2p. So total 3 orbitals. It means they must form 3 bonds. Yeah. So here 4 bonds. Okay, cannot. 4 bonds cannot. 1, 2, 3. The double bond is not counted. So 1. This is 2. No, not counted. 1, 2, not counted. 1, 2, 3, counted. 1, 2, 3, counted. Okay, 1, 2, not counted. 1, 2, not counted. 1, 2, 3, 4, not counted. So if you look over here, the one that is going to be sp2, okay, did I miss anyone? Okay, let's check again. Okay, sp2. No. Okay, let's check again. Yes. No. Yes. 1, 2. Not. 1, 2, 3. Can. 1, 2, 3. Can. 1, 2. 1, 2. 4. Cannot. So total 4. Okay, you can see over here. Okay, there are total 4. Okay, which is going to be B. Okay, B will be the answer. Next. This one, okay, no need to have to know like some kind of a formula or something to answer this. Okay, when they say how many stereoisomers are there, first of all, you see this one, there is a possibility to have cis and trans. Okay, then after that stereoisomer, please look for optical isomerism. Okay, the chiral center. No chiral center. Okay, no chiral center. Okay, there is no chiral center here. Okay. No chiral center here. Okay, no chiral center here. No chiral center here, no chiral center here. None. But here, okay, you can see hydrogen OH, this one, there is a chiral center here. And then here, okay, there is CH, okay, there is going to be chiral center here. Okay, there are two chiral centers here. Okay, so if you have for this, let's say if you focus on this, okay, this one has a chiral center. It means that it can form two optical isomerism. Okay, two optical isomerism for this, yeah, for this carbon. And then do remember, from these two optical isomerism, there is going to be cis and trans. Okay, it means that there is cis, there is trans, there is cis, there is trans. Okay, and then this is number one. If you take from number two, okay, optical isomerism, they have two. Okay, they have two. And from there, because you have this double bond, so this optical isomerism have cis and trans. They have cis and trans. Okay, so in total, okay, how many stereoisomers are there? 1, 2, 3, 4, 5, 6, 7, and 8. Okay, so that will give you the answer, which is going to be 8 over here. Z, can you understand this?
Yes, sir.
Yeah. Okay, so I do not want, okay, you to memorize any formula. Okay, I think this one, using this method enough already. Okay, just need to think, okay, and then apply. Yeah. So I think this one no need to use formula. Okay, 26 is going to be D. Now structural isomerism should be only structural isomerism should be considered. So how many straight chain isomer, okay, are there, okay, with molecular formula of this, okay? So we want to find out how many, yeah? C4, okay, C4, straight chain, yeah? Straight chain, so can have Cl here, Cl here, can have Apple Pencil getting disconnected. Okay, wait. Okay, so you can have also C, 1 Cl here, 1 Cl here. I can have 1 Cl here, 1 Cl there. I can also have Cl here, Cl here. I cannot break them. Okay, I cannot break them. Structural isomerism. How many straight chain isomer? Okay, so then I can also have this one, same carbon, Cl here. I can also have Cl here. I can also have Cl here. Okay, so I cannot bring it over here. So total 1, 2, 3, 4, 5, 6. 6. Okay, the answer is going to be 6. Now, next question. What is true about every nucleophile? Nucleophile, they like nucleus because they like positive. Yeah. So they attack double bond. No, double bond has electron. Okay, that is electrophile. Okay, it donates lone pair of electrons. Okay, yes. Okay, a single atom, not really. Yeah, it can be also ion. Okay, it is negatively charged. It can be positively charged also, doesn't matter. Can be atom also. So as long it has lone pair of electron, it will be attracted to positive. So the answer is B. Now the diagram shows a synthetic route, okay, to produce this methyl cyclohexanol. Okay, what is region Y? Okay, what is region Y? So here, when you use HBr, okay, what happens? Okay, if you want OH here, okay, if you want OH here, it means Br must come somewhere here. So the product X, okay, is supposed to be something like this. CH3, and then the Br came over here, the H came here, the double bond is broken already. Then from Br, we want to change it to OH, okay? So how do we change Br to OH? It must be something to do with the substitution. Okay, so the substitution is going to be definitely by using aqueous sodium hydroxide. Okay, so cannot use ethanolic. Okay, ethanolic is elimination. Okay, so we use aqueous sodium hydroxide. So A. So next. So X and Y are regions required to convert, okay, this to butanoic acid. But you see, yeah, from Br to become CN, so definitely this one must react with KCN. Okay, so KCN must be in ethanol. Okay, so KCN must be in ethanol. Yeah, KCN in ethanol. And then from here to change to this, remember, must be acid with water. Okay, the equation. Okay, I taught you already. Okay, so must have, okay, ACl, okay, and aqueous. Okay, so this one must be ACl, so the answer must be C. So this is what we learned towards the end. Yeah, carboxylic acid and nitrogen compounds. Okay, now 31, okay, the table shows 3 sets of reagent and reaction condition. Okay, so you have, okay, reaction condition, room temperature, presence of ultraviolet light. Which set can be used to produce propane? So 3 propane, 2 methyl, so CH3, and then 2 chloro. Okay, we want to produce this. So here, okay, in the carbon number 2, there is OH. And then here, okay, doesn't matter. Yeah. So here, okay, when they want to produce the Cl coming here, okay, if you want to have Cl going there, okay, that is going to be, you can use the reaction of react with ACl, okay, at room temperature. This is going to be you are going to have, okay, the Cl coming over here. Okay, so here if you are using a SOCl2, okay, SOCl2, and then Cl can replace over here, which is the OH can change into Cl, so this one definitely correct. Okay, and then here the H over here can be replaced by free radical substitution. That is possible. Here, okay, just to check, yeah, CH2, then you have CH3, and then CH3. It means there is double bond, okay? So double bond, that's why they react with ACl, okay? Where the Cl, okay, can come over here, H can go here. So the Cl can come in the middle, okay? CH3 is there, so possible also, okay? So that is going to be, this is going to be electrophilic addition, okay? This is going to be nucleophilic substitution, free radical substitution, electrophilic addition, nucleophilic substitution, and this is going to be free radical substitution, okay? So this is going to be A. 32. Which are the only structure, okay, butan to all, okay? Butan, okay, to all. OH is here. So when you hit with this, okay, the H from here, okay, can come out. So you have this possibility. Or the H from here can come out. So you have C, like this, okay? So when I look over here for second, H and H, no cis and trans, okay? Cannot have cis and trans. But for this, because the carbon is attached to 2 different groups, okay, CH3 and H, this is CH3 and H, there is possible to have cis and trans over here. So there will be cis and trans over here, okay. Issue connecting with the Apple Pencil. Let me try again. Okay, cis and trans, and only this. Okay, so let's check. So this is only this, no cis and trans. Cannot be the answer. Must be 3, yeah. So only this, okay. Then must have cis and trans, okay. CH3 cannot be this, okay. Cannot be cis and trans like that. Okay, this is trans. Okay, this is cis. Two different. The answer is B. Okay. Now, 33. The compound leaf alcohol is partly responsible for the smell of new mown grass. Okay, what will be the will be formed? Okay, when this is going to be oxidized, okay, using hot acidified. So please remember, hot acidified, the double bond is going to be broken. Yeah. So C double bond C H H, and then they have CH2 CH2OH. Then I have CH2 CH3. Now, when I break this, okay, this is going to be R group. Okay, there is H. So this one is aldehyde. So you will get C2H5. And I told you when you have aldehyde, it will be oxidized further to become carboxylic acid. Okay, this one. And this one, okay, this part, okay, is going to be also going to be C, okay, aldehyde. Okay, but please remember, okay, it will be oxidized further to become carboxylic acid. But do remember there is going to be this entire thing. Okay, if I connect this C2H5OH, this is going to be primary alcohol. Okay, 1R group. Okay, over here. The primary alcohol can be also oxidized, okay, to become carboxylic acid. Okay, so even this one also will change into carboxylic acid. So you will have C double bond O, so OH, so this part, and then I have C double bond O, OH. Okay, I will get something like this. So what will be formed? Okay, there will be two carboxylic acid. Okay, done. And then OH and OH. OH and OH. 3 carbon. All done. The answer is C. Responsible. What will be leaf is oxidized using excess of hot acidified. And this. Carboxylic acid. Let's see. Excess hot acidified. Hot acidified. Definitely hot acidified, you will oxidize. This will be broken. Okay, I need to check whether the answer I checked correctly or not. Yeah, I think it's D. Okay, let me check. I think to save time, okay, we check. Yeah, I think the answer should be D. Yeah, I checked just now it's C. Okay, but let's check. Okay, this one should be this and this. Okay, so this one I think D. But if it is wrong, then later we can check again. Yeah, I'll put it in the comments also for the YouTube. Now, for the 34, okay, compound X, okay, does not react with tolerance region. Okay, if it is does not react with tolerance region, then it must be ketone lah. Okay, so aldehyde must react with tolerance region. Okay, it forms a yellow precipitate. Okay, does not react with sodium. Okay, does not react with sodium. So if it is aldehyde, cannot be aldehyde. Okay, because aldehyde should react with tolerance region. Okay, here this is a ketone. Okay, for B, does not react with tolerance region. Correct. Okay, ketone do not react with sodium. Correct. Forms a yellow precipitate because the C2H5, C double bond O, and then there is CH3. Yes, there is going to be yellow precipitate. This is going to be B. Ester, okay, ester, okay, nothing to do with tolerant. Okay, ester cannot give you yellow precipitate with alkaline I2. Okay, and even alcohol also. Okay, alcohol they do not react. Alcohol reacts with sodium. Okay, alcohol reacts with sodium, so therefore this one cannot be the answer. Okay. So 35, which compound can undergo nucleophilic addition? Nucleophilic addition must be carbonyl compounds. Okay. So carbonyl compounds, okay, it can be ethanol, okay, ethene, all this cannot, yeah. So here. So this one is going to be ester reacting with aqueous acid. Okay, ester with aqueous acid. So the product from the reaction, okay, is reacted with this to form two molecules. Okay, so C2H5, C double bond O, OCH3. Okay, so when you react with acid, okay, we know that hydrolysis will take place. So here you will have C2H5, C double bond O, OH. This one will be CH3OH, okay, alcohol. So it's a primary alcohol here. Now, so the reaction is reacted with this. So this one is going to be reducing agent. Okay, you cannot reduce alcohol. Okay, but you can reduce this. Okay, reduce carboxylic acid to form two molecules of Y and Z. Yeah, so they say two molecules of Y and Z. So carboxylic acid can form, okay, aldehyde. Okay, it can also form a primary alcohol. Okay, because it's a strong oxidizing agent. So it's first can a strong reducing agent. First, it can reduce to aldehyde. Then after that, it can reduce to primary alcohol. So first, okay, first is going to be, sorry, it is reacted with aqueous acid. What are the identities of molecule Y and Z? If it is the product are reacted with this. Okay, sorry. So when they say the products, okay, they mean this product and this product, they react. Okay, so this one cannot react with the LiAlH4, so they will remain as it. Okay, but no aldehyde will be formed, okay, because it's a strong reducing agent. So straight away, okay, from the carboxylic acid, they will straight away form the primary alcohol. The alcohol is C2H5, then COH, and this one is hydrogen and hydrogen. So you will have C2H5, CH2OH. So the answer is D. Okay, now 37. So a sample of propanoic acid react with excess of magnesium. So a second sample of propanoic acid, okay, reacts with excess of sodium. Both, okay, form gas. Okay, so propanoic acid C3H7. Propanoic acid is C2H5COOH plus magnesium, C2H5COOH plus sodium. Now the difference over here is Mg is 2 plus. So you will have C2H5COO2 and then Mg2 plus here. So or Mg plus half H2 hydrogen. So when I balance this, okay, this one should be 2. So this one no half, okay, plus hydrogen gas. And this one will be C2H5COO and then Na plus half H2. Okay, so the difference is one is going to be 1 mole of H2, another one is half mole of H2, but this is for 2 moles. This is 1 mole. So they are using the same. So if I write the equation, okay, let's say we want to compare the gas, okay. If I put C2H5COOH plus half Mg, it will give you, rather than just keep it as it is, okay. Let's say here, okay, volume of gas, okay, formed with sodium, volume of gas formed with this. So do remember we want for 1 mole, yeah. Okay, we want for 1 mole. So for 1 mole, this is for 2 moles. Okay, this is 1 mole. So definitely the volume will be different, cannot be the same volume. Okay. So 3.7 divided by propanoic acid. So Z, can you help me? Okay, calculate the MR of C2H5COOH and then find out the number of moles.
MR is 77.
77. How many moles? 3.7 divided by 77.
0.048.
So if let's say volume of gas formed with magnesium. Now here, if 2 moles, this one should be if I change into 1 mole, this should be half. So 1 mole, let's say I'm talking about 0.048. So this one will give you 0.024. If I take 0.048 over here, this one will be also 0.024. So the volume of the gas must be the same. Okay, please check which will be the best volume. Yeah, so 0.024, okay, times 24 dm cube, then change to cm cube. One dm cube is 1000 cm cube, so you need to still times by 1000.
So the mole is 0.0. Wait. 0.05. Sorry.
Okay, 0.05
Times by 24 is
So when you times by 24, what do you get?
0.6.
0.6.
All times 1,000 is 600.
Okay, around there. Okay, I think because we simplify it. Okay, so the answer should be around 560. Okay, just check the calculation again. Okay, but again, the value should be 560. Okay, you get 600. Okay, let's move on. 38. Okay, so which statement is correct about this? So this one is going to be ester. This one is going to be alkene. So it can be hydrolyzed, okay, to a secondary alcohol, okay, hydrolyzed, okay, to a alcohol, okay, not really. It can be made using ethanoic acid and suitable alcohol, yes, but they forget about the alkene, yeah, so cannot. It gives a positive test with alkaline I2, okay. That is for something that contains OH and carbon double bond O, yeah, the ketone, yeah, carbonyl compound, no. So when treated with hot acidified KMnO4, okay, it gives you as one of the products. So the what happened, okay, maybe it's broken over here, okay, then you can have the carboxylic acid there, okay, and then you can also have this, yeah, possible, this part, okay, it can be oxidized, okay, to give you this. So the number of carbon also 1, 2, 3, 4, 5, 1, 2, 3, 4, okay, 1, 2, 3, 4. Treated with hot, it gives us one of the product. 1, 2, 3, 4. Yeah, I'm just concerned with the number of carbon. Okay, if we break over here, you will have 1, 2, 3, 4, 5 carbon. 1, 2, 3, 4. Only 4 carbon. Okay, 4 carbon.
Sir, the CH3 is a branch.
Yes, it's a branch, but because, okay, what I mean is you have CH2 and then double bond C, then CH3 is the branch. Then you have CH2, C, double bond O, O, CH3. Okay, so when you break this, so of course you will get carbon dioxide and water. And then when you do this, so you will have a ketone. Okay, so ketone will be there, CH3, then C double bond O, CH2, C double bond O, OCH3. So why carboxylic acid? When treated with hot or concentrated, it gives carboxylic acid hot KMnO4. Yeah, I'm confused with the carboxylic acid. Yeah, maybe there is a particular reaction that breaks this. Okay, but it's okay. The rest, okay, definitely cannot be the answer. Okay, so the answer is going to be D. So they say it gives as one of the product. Okay, then possible. Okay, ketone is there. Only this part is like I'm confused. Ester oxidize, or because it reacts with acid, yeah, then possible. Okay, if the ester, because there is acidified, so what happens, okay, acid can actually hydrolyze the ester bond. So when you hydrolyze this, so you have 1, 2, 3, 4. 1, 2, 3, 4. Yeah, possible. Okay, so there is also acid hydrolysis here. Okay, yeah, D will be the answer. Okay, 39. So polymerization. Okay, so which one? You have this. Okay, and you want this. So there shouldn't be double bond. Okay, shouldn't be double bond there. So you have CHH, this bond, then CH, then CH2OH. Then should be like something like this. Okay, CH2, CH, cannot, CH2, CH, this one, so cannot. Okay, so B will be the answer. So 40, okay, the last one, okay. So 40, you have, okay, the mass, okay, very interesting question as well, okay. The mass spectrum has a molecular ion peak at 176, relative abundance of 7%, okay. So we want the abundance of M plus 1 peak, okay. So calculate the number of carbon first, 1, 2, 3, 4, 5, 6, okay, 6 carbon. So the formula is N equals to 100 divided by 1.1, okay, times the smaller, okay, which is going to be the M plus 1, then M over here, okay, that peak. So this is 600, 1.1, M plus 1 peak is, we don't know, okay, so we have this as 7%. We want M plus 1. So 6.6 divided by 100 times by 7 is M plus 1. Okay, Z, you help me.
0.462.
Okay, that, okay. So you have A over there. Okay, although we, yeah, I did take some time to discuss this, okay? But there are some questions that we need to revisit again, okay? I think, let me check which question that we need to revisit. Okay, but that one, okay, the question that we are revisiting, maybe I'll just put it in the comments and or in the class WhatsApp group, I will just tell you, yeah. So thank you guys, okay, for those who are still staying with us, okay. Thank you for joining. See you guys. Bye.
Thank you, sir.
Any questions before we end? Okay, no question. It's okay. See you. Bye.
Bye,
Thank you,
sir.
sir. Bye, sir.